Hey everyone, welcome back to Chemistry 1, Finding Empirical Formulas, where today we are going to go over easy practice problems. And we're just going to get right into it. So question number 1 is saying that a sample of a compound yields 1.23 grams of hydrogen, 12.64 grams of phosphorus, and 26.12 grams of oxygen. What is the empirical formula? Using the strategy scheme that I posted in the video before this one, whenever we have to look at what we're starting with and see what the next step is. So I'm going to write the scheme out really quick, but whenever you have grams, you want to go to mole. And in this problem, everything's in grams. So that's what we're going to start with. 1.23 grams of hydrogen. So if we have grams at the top, grams at the bottom, and then 1 mole of hydrogen, we know that the molar mass is 1.08 grams. Once we do that math, it's 1.220 mole of hydrogen. And we're going to do this for all elements involved. So we have hydrogen, phosphorus, and oxygen. Oxygen is stated to have 12.64 grams of phosphorus. So grams of phosphorus can be converted to moles of phosphorus, and per the periodic table, the bottom is going to be 30.67 grams. Do that math, we end up with 0.407 moles of phosphorus. And then lastly, we have 26.12 grams of oxygen. 1 mole of oxygen. Periodic table states it to be 16.00 grams. And that math comes out to 1.633 mole oxygen. Now, let me do this. We next have to, I'll put here, divide smallest mole. I'll put divide by smallest mole value. So which one's the smallest? That'd be this one. So everything's going to be divided by that. So we have hydrogen, 1.220 divided by 0.407. That comes out to 2.997, which is approximate to 3. Then we have phosphorus, 407 divided by itself, 0.407, 1. And then oxygen, 1.633 divided by 0.407 is going to be 4.012, which is approximate to 4. Therefore, the formula is H3P1. I'm not going to write it down because it's understood, and O4. Alrighty, so a sample of a compound contains 0.17 mole boron and 0.255 mole of oxygen. What is the empirical formula? So in this situation, we already have mole, so we don't have to go from grams to mole. We just need to divide by the smallest mole amount that we have. So for boron, and the smallest gram amount is this one. So for boron, 0.170 divided by 0.170 equal to 1. And then oxygen is 0.255 divided by 0.170 equal to 3.92, which can be rounded up to 4. Therefore, the formula empirically is B1 and then O4. Next problem is a sample compound has 0.903 grams of phosphorus, and 6.9 grams of bromide. What is the empirical formula? Similar situation. We are going to go from gram to mole, because here we have grams. .903 grams of phosphorus. I'm going to go to moles, so grams of phosphorus at the bottom, 1 mole of phosphorus at the top. Periodic table states it to be 30.974. Doing that math is 0.029 mole of phosphorus. Now we have 6.99 grams of bromine. Grams of bromine at the bottom. And doing our dimension analysis, so mole of bromine goes at the top, and the periodic table states that this is 79.904. Once we do that math, it's 0.087 mole. Next step, divide by the smallest mole. The smallest mole here is 0.029. So 0.029 mole phosphorus divided, well, we don't have to put that part. Divided by 0.029 is equal to 1. Then for bromine, 0.087 divided by 0.029 gives you 3. Therefore, the formula is PBr3. And then our last problem says a compound's mass composition is 40% carbon, 6.71% hydrogen, and 53.3% oxygen. What is the empirical formula? So when we have percentages, we need to add them all up to see what it comes up to. So 40 plus 6.71 plus 53.30 equals, oh, that doesn't look right. Hold on. Do it again. 40 plus 6.71 plus 53.3. 100%. So approximately 100. Knowing that it's 100 means we can, that means that we can substitute wherever it says percentage and change that to gram and use that information to follow the same process that we've been doing before when we have grams. So now that really is 40 grams of carbon doing the math gets me to 3.331 mole carbon, 6.71 grams of hydrogen. 1 mole of hydrogen gives you 1.008 grams of hydrogen. Once we do the math, that's 6.657 moles of hydrogen. And then 53.3 grams oxygen. Grams of oxygen, 16. 1 mole oxygen. 3.331 mole of oxygen as well. Carbon, Now, the smallest is tied here for carbon and oxygen. So we're going to pick one and just divide all of them by 3.31. Equals 1. 6. 1.99, which we can approximate to 2. That's going to be 1. Therefore, the formula is CH2O. Alrighty, that's the end of the practice problems I have that are relatively easy. The next one will be about some that are a little bit more difficult. See y'all in the next video.